Almost all design and construction nowadays is digital. The application of digital design tools can bring many benefits to the development of a project. Digital tools include both machinery, for example CNC technologies, and software such as CAD, 3D visualization and BIM tools. Building information modelling is a key tool for digital design and one we'll focus on in this video. Offsite offers more opportunities for integration of digital technology into the design process through CAD/CAM application. This is computer-aided design and computer-aided manufacturing. With off-site construction in the factory environment, there are a lot of opportunities to use semi-automated equipment in production. Instructions can be generated from the design model, in this way bridging the gap between design and manufacturing. The REBA plan of work with its 8 stages is used throughout the industry in both offset and traditional construction processes. The main difference in the design stages when designing digitally for off-site construction is the so-called early design freeze. This is the stage before manufacturing starts, when all aspects of the design need to be agreed and finalised. This can be very detailed, for example right down to the style of the kitchen cupboard handles. This is a very important change in the mindset for designers, compared to traditional process where changes to the detailed design sometimes occur while the building is in construction. One of the main benefits of this early detailed design stage, when combined with BIM, is the so-called digital twins. These are digital-rich component-based models of entire projects. This helps to show the stages of the construction process to Industry 4.0 through detailed analysis of the building's performance before any of the works begin on site.
This is an example of a parametric component. I select the object and now have the ability to change numerous facets about this. This is currently showing a beam in post. Now my beam is at a lower position. If I want to have the beam at a higher position, I can simply select that, press apply, or I can change any other characteristic about this part. Or if this component wishes to be a racking wall made from cross-laminated timber, I can simply select that. Or if this wall wanted to be a component made from timber frame, I can simply select that, press apply, and there's a timber frame there. If I go back to the racking wall made out of CLT for just now, and if I wish to add a window within here, I can add a window or a door or any form of opening. I can then specify the height, sizes and location of this opening.
For example, if embodied carbon data is provided for each of the materials contained in the model, designers can manipulate the building's embodied carbon footprint with relative ease.
We can look at the BIM model using the layout tool. Anything that's changed within the original model instantly and automatically gets updated within the layout. So we've got one source of true information. And this one BIM model creates the entire cutting and manufacturing drawings. And there's examples here. So we've got a panelized drawing here, and above it we've got all the weights and the global warming potential for this. If I zoom into one, you can see the cutting list for that one panel. So on the summary for this project, we can calculate exactly how much material of what type was used, and within that we've already captured the global warming potential for this. So for this project here, we have the summary output categorising that, and also your full cutting list and order list for the project.
The same goes for time and cost analysis with 4D and 5D BIM simulations, which add additional dimensions to the traditional 2D and 3D models. The application of digital design in offsite and BIM can also have its challenges. In the digital design market, there are large, ever-increasing numbers of software programs and associated file formats. Even within one organisation, you will often find that different people have different preferences for the tools they use and how they use them. Thinking of a typical large-scale residential development, there will be many project partners, each with different software conventions. The interoperability of these tools and their naming formats are often so complex that Specialist BIM Manager is sometimes employed to decide and maintain the necessary file formats and version control across different software packages. Often the models from different partners are overlaid in one single model using the Industry Foundation class, or IFC, file format. The application of BIM tools for off-site construction is often very exciting, as new developments keep on emerging in the market. Today we are filming at the Trimble Technology Lab at Napier, and we will show you a few tools including SketchUp Pro, Techlit Eds, a drone and a scanner. This is only a snapshot of the technology available at the moment. With future developments, we expect to see increased usage of virtual reality and augmented reality design for off-site construction projects. With virtual reality, we can develop more interactive training courses, such as in the Convert project, where an off-site timber frame, single-family home can be constructed by students and learners at all levels. Similar virtual learning environments can be created for the on-site assembly of off-site systems, thus providing any health and safety training to cover any risks. Augmented reality, where the data-rich BIM model is overlaid on top of the actual reality, which offers even more greater opportunities for the use of digitisation during manufacturing and construction. One of the immediate applications of augmented reality can be within quality control. As designed and as constructed versions of the model can be directly overlaid to identify any differences and correct them before handover to the client. In summary, the application of digital design tools in off-site manufacturing is enhanced through CAD/CAM design processes. One of the main differences to be aware of in off-site construction is the early design freeze compared to traditional construction. In this, BIM tools with 4D time and 5D cost analysis can be used to predict and optimise the performance of a project during construction. A challenge in this process can be the vast array of tools available with different file extensions. A solution to this is often Industry Foundation class, IFC, file type. In the near future, we are likely to see increased use of virtual reality and augmented reality for training, design development and quality control. Congratulations, you are now off-site ready with knowledge for change in digital design.